Hi, welcome back. We're continuing to look at compound inequalities. So in the last video, we looked at two basic cases. So we had one where it was written with the and the other where it was written with an overlap. We're now going to look at these two interesting cases. So I have x is less than or equal to -1 and x is less than 4. So let's start. So I have -1, 0, and 4. So I have x is less than or equal to -1, which is going to be a shaded circle at -1, shading to the left. Then I have x is less than 4, which is going to be an open circle at 4, shading to the left. And then I have their overlap. So when I look at this, both of these are shaded at -infinity. So that means I have a shaded arrow in my solution. So this is the and. Okay, so they're shaded they're both shaded here all the way up to and including -1, but nothing to the right of that. So this ends up with a solution -infinity to -1 inclusive. So when I look at this, what this is saying is, if I were to talk about this in terms of a real life situation, this would be like everyone, let's say everyone 10 years and under, and 15 years and under. If I gave these two age restrictions to attend an event, you would say, why would you even bother saying 15 and under? 10 and under is the only one that really matters. If you have to both simultaneously be less 10 or younger, as well as being 15 and under, everybody who meets the criteria, this and criteria, is going to be 10 years or younger. Another way to think about this is if we were talking about going on a roller coaster and I said everyone has to be, to ride this ride has to be at least 4 feet tall and at least 3 feet tall, you would say, why would you bother saying 3 feet tall? Anyone between 3 and 4 feet can't ride because they haven't met that 4-foot criteria. So this is a possibility. In Algebra 1, you likely only saw the and inequalities that produced the area in between. In Algebra 2, we're going to see a lot of these special cases. Another interesting case we have here is x is greater than 9 and x is less than 2. So I have 0, 2, and 9. So I'm always including 0 on my number lines, and then I'm including any other key points. So in this case, it's 0, 2, and 9. All right, so x is greater than 9. Open circle at 9, shade to the right. X is less than 2. Open circle at 2, shade to the left. Now, when I'm looking at the overlap, there is nothing that meets both criteria. So this is no solution. There is no value that meets both of these criteria at the same time. So this would be like saying, in order to go on this ride, you have to be at least 4 feet tall, but no taller than 3 feet. There's no one who is simultaneously taller than 4 feet and shorter than 3 feet. So this would be a no solution case. So again, we're going to see a lot of these interesting cases of compound inequalities in Algebra 2. So you want to make sure that you're stepping through the process when you get to a compound inequality.